16 BC 5. Cool. Consider the function f of x equals 1 over the quantity x squared minus kx, where k is a non-zero constant. The derivative of f is given by this, which is really them just doing you the solid and deriving it for you. Like, you could find this derivative. It's not anything earth-shattering, but they were just trying to help you out. Part A, let k equal 3, such that f of x equals 1 over x squared minus 3x. Write an equation for the line tangent to the graph of f at the point whose x-coordinate is 4. Okay, so part A is telling us that we're going to use the specific function where k is 3, right? Meaning that f of x equals 1 over x squared minus 3x, and f prime of x, I don't have to find from scratch. I can just use this formula they gave me, and anywhere I see a k, I put in a 3. So 3 minus 2x over, in parentheses, x squared minus 3x quantity squared. Great. They want the equation of a tangent line. Remember, anytime you're asked for the equation of a line, right, in all of math, no matter how hard these problems get, you need two things. One, you need a point. Well, they gave us that the x-coordinate of the point is 4, so 4 comma f of 4, which I'm going to have to find, right? And then I need a slope, right, which, since it's a tangent line, the slope should be f prime of 4. I should be able to find both f of 4 and f prime of 4 pretty easily because I was given both of those formulae. So f of 4 is a 1 on top of a 16 minus a 12, right? So that's a 1/4, right? And f prime of 4 should be a 3 minus an 8 on top of, well, we already established that this denominator is a 4, and this thing is that denominator but squared, so that should be over a 16, so I get negative 5/16. So it seems to me that my tangent line, if I write it in point slow, should be y minus the y value, which was a 1/4, equals m, that's the negative 5/16, x minus the x value, which is a 4. Now, they did not ask you to solve for y, so this answer is totally fine. But if you want to go the safe route of just saying, hey, I solved for y, but I didn't really do a whole lot of work, you can just add the 1/4 over outside of the parentheses and say, hey, plus 1/4. I would not suggest distributing the negative 15/16 and cleaning up, because the more math you do, the easier it is to make a mistake. Part B. Let k equal 4, such that f of x is this same formula, but with a 4 instead of a 3. So let's go ahead and use k equals 4. So part B, let k equal 4. All right. Determine whether f has a relative minimum, maximum, or neither at x equals 2. Okay, so I would suggest, just so you don't do something crazy, that you go ahead and write exactly what f and f prime would be in this situation. So x squared minus 4x, because k is 4, and my f prime in this situation is 4 minus 2x over an x squared minus 4x quantity squared. Cool. Okay, so the question was, what's happening at 2, right? Well, if we're asked about extrema, right, so if we're asked about extrema of f of x, means that we're supposed to use f prime of x, right? We're supposed to find critical points and see if we have maxes and mins. So let's go ahead and find the critical points for f by saying that they occur either when f prime is 0. Well, that would be when the numerator, which is 4 minus 2x, is 0. So 4 equals 2x and x equals 2. So that verifies that 2 is definitely a critical value, right? One easy way to test this is that 2 is a critical value. I could test the number on either side right next to x equals 2 and see if I get a positive or a negative for f prime. But if you want to be extra safe, the other kind of critical points are when f prime does not exist. But in this case, that's going to happen when x squared minus 4x is 0, which is that x is 0 and x is 4, which are both vertical asymptotes of the original function. Right? They're both vertical asymptotes of f of x. Which essentially means that whatever's happening at 2 is happening in between two vertical asymptotes. So really, if I go ahead and make a little sign chart, right, for my f prime, I know that at 0 there is a vertical asymptote for f, right? And I know that there's a vertical asymptote for f at 4. And so at 2, all I need to do to figure out if my function has a max or min is test a number on either side of 2. So if I plug in f prime of 1, right? If I plug in f prime of 1, I'm going to get a 2 on the top over a number that has to come out on the positive on the bottom because it's squared. So I'm going to get a positive here, right? And if I plug in f prime of 3 here, right, I'm going to get a negative 2 on the top over a number that has to come out positive. So it's negative. What that means is that f must be increasing and then decreasing. So I have a max. So there's a bunch of different ways to see that, right? The other logical way to see it is to realize that if you were to make a sign chart for f double prime or for f prime, this denominator is always positive. So this guy is going to behave like a line with a negative slope, and in the sign charts that we've seen before, a line with a negative slope is positive, crosses 0, and becomes negative. So positive crosses 0 and becomes negative. So you've got a max, and the way to explain it is that your f prime changes sign from positive to negative. So for part B, right, for part B, my answer is going to be that at x equals 2, f of x has a max because f prime of x changes from positive to negative. Cool. Part C. Find the value of k for which f has a critical point at x equals negative 5. Okay, so in C, here's what we know. We know that x equals negative 5 is a critical point, right? Now, notice that that's not one of the vertical asymptotes. Like this function, if you look at the original function, right, this original function has vertical asymptotes at x equals 0 and x equals k. That's not a critical point. A critical point is a place where the derivative is 0 or doesn't exist, and although vertical asymptotes matter, it's not the same thing. It's not a critical point because it's not a point on the graph. So what we're looking for here is we want to know where f prime of x equals 0. That's what a critical point would be. So we're saying that k minus 2x equals 0 at x equals negative 5. Well, that would be k minus a 2 times a negative 5 equals 0. That's k plus 10 equals 0. So k has to be a negative 10 to have a critical point at that value, right? There's a bunch of different other ways to say it. The other way to do it, if you didn't want to logic through it this way, is to just recognize that this has to be true. So if they're saying, so the other way to logic through this is to say, oh, I get it, f prime of negative 5 must be 0. And then you could plug in and say k minus a 2 times a negative 5 over a negative 5 squared minus a k times a negative 5 has to be 0. And then this numerator is going to end up being what matters, and that spits you right back to there. Part D. All right, part D. Let k equal 6 such that f of x equals 1 over the quantity x squared minus 6x. And here's the part that makes it a BC question. Find the partial fraction decomposition for the function f, and then find the integral of f of x dx. So I'm going to go ahead and erase these guys because now I only need the one that we have since we're on part D. So I'm told that f of x in part D is 1 over x squared minus 6x, which is a 1 over x times the quantity x minus 6, right? So that's going to decompose into an a over x plus a b over an x minus 6, right? So the first thing I'm asked to do, sorry, my bad, too far that way, okay? So the first thing I'm asked to do is the partial fraction decomposition. So I mention that because that's not technically calc, right? Partial fraction decomposition is not technically calc. And I know that 1 over this x times x minus 6 is apparently an a over x plus a b over x minus 6. So what I want to do is I want to get a common denominator that is the original denominator. So I'm going to multiply the a over x by an x minus 6 over x minus 6, and the b over x minus 6 by an x over x. What's going to happen is that since the denominators are exactly the same, essentially they disappear. What really happens is you can multiply the entire equation by those denominators, but in reality, since this denominator will end up being identical to the other, I can ignore it and just pay attention to the numerators. So I get this. I'm then going to do what I call clever substitution. I notice that if I plug in x as 6, I will knock out this term and be able to find b. So I get 1 equals 6b. Oh look, 1/6 is my b. If I plug in x as 0, I'm going to be able to do the same thing and knock out this term. So I get 1 equals a times negative 6. Oh look, negative 1/6 is my a, right? So now my partial fraction decomposition is that f of x is a negative 1/6 on top of an x plus a 1/6 on top of an x minus 6. Or if you want, you can yank out the 1/6 and be like, hey man, I'm just not about that life. That's kind of annoying. It's up to you. So that's the first thing I was asked to do. I was not asked to integrate yet. Like, I am asked to integrate as the second skill, but this is a first skill that they ask for. Make sure you do all of the specific prompts, right? This prompt was requested. You have to do this bit. Now you're asked to integrate f of x, now that you've done the decomposition. So I'm essentially just going to yank the 1/6 out, right? So this is a 1/6, the integral of 1 over x dx, plus a negative 1/6, the integral of 1 over x dx, plus a 1/6, 1 over x minus 6 dx. Those are both natural logs. So I get a negative 6 in front of, or negative 1/6 in front of the natural log of the absolute value of x, plus a 1/6 in front of the natural log of the absolute value of x minus 6, plus a c, right? And I was not given a value to find c. So I'm stuck with it. So this answer is not wrong. The other way you might see it is the 1/6 factored out, right? And if you factor out the 1/6, right, if you take out a 1/6, the other thing you might notice is that technically you could combine these into, because of the subtraction, you can combine them into one natural log with the x minus 6 on top and the x on the bottom, right? That's great. Plus c. That's a fine answer too. Either of those answers are fine. The big thing here is that I would suggest you be prepared for this if it were a multiple choice question, because they like to use log properties in multiple choice.